Okay, we're going to do notes on right triangles, and we're going to look at some different things here. Now, some of this will be review, things you did in middle school. So we're going to start with what is called the Pythagorean Theorem. So again, this should be something you have done in middle school, Pythagorean Theorem. And this is used with right triangles. And you may remember this, a squared plus b squared equals c squared. Now, whenever we're talking about A and B, these are the legs of the right triangle. C is called the hypotenuse. Now, what makes it the hypotenuse? Two things. It's the longest side, and it's across from the right angle, which in the picture here is the square. Whenever you see that square, that's the right angle. So in this case, 12 would be the hypotenuse. In this case, 13 is the hypotenuse. So what we're going to be doing is finding the missing side by plugging into this formula and then solving. So in this particular case, for number 1, we have, again, a squared plus b squared equals c squared. Now, it doesn't matter which one you label as a or b, so I'm going to put 8 for a, x for b, and then 12 for C. Now, one thing I'm not doing here in this formula is using parentheses, but the reason I'm not is because with geometry, all measurements have to be positive. So then we solve 64 plus x squared equals 144. Now we're back to solving a quadratic. In this case, because we just have an x squared, I can do this by the method of taking the square root. So we get rid of our numbers and get x squared is 80. And then I take the square root of both sides. Now, typically, in the other lessons, what we've learned is whenever you take the square root, you always have two cases, a positive and a negative. But in this specific case, because, again, it's geometry, we're talking about a measurement, you cannot do the negative case. So I get x is square root of 80. Now, if you read the directions, it says in simplest radical form. So I have to break 80 down. So I'm going to come over here and break 80 down. Well, a square that's a factor of 80 is 16. 16 times 5. Well, the square root of 16 is 4. So I end up over here with 4 on the square root of 5. So that's how you use Pythagorean Theorem. What I'm going to do next is just work this other one out over here, but not really talk you through it. I'm just going to show you the work so you can see it and hopefully relate it to number 1, and then we'll go to the next portion. So number 2 has been worked out over here on the side. You get square root of 105. That will not simplify. Okay. Next is state if each triangle is a right triangle. So in this case, what you've got to do is use Pythagorean Theorem in reverse. We call it the converse in geometry. But we're still doing the same thing. What we have to identify is which one potentially is the hypotenuse. So in this case, since they're all square roots, we pick the largest one. In this case, that is square root of 14. So potentially this could be our C. Now I don't know for sure until I plug it into the formula, but the longest side again is always going to be the hypotenuse. So again, it doesn't matter which one you label as A, which one is B, as long as they're the two shorter ones. So I have A squared plus B squared equals C squared. Now, what happens when you square a square root? Remember, those cancel, so I get 6 plus 7 equals 14. 13 equals 14. Now, that is a false statement. That is not true. So what's that mean? This is not a right triangle. And this is the symbol for triangle right here. So again, what I'm going to do is pause the video. I'm going to work number 4 out over here on the side, let you see the work, just to do it again. Now, one thing I will show you before I do number 4, since not all of these numbers are square roots, I don't know what square root of 10 is. So the first thing I'm going to do is punch square root of 10 in on my calculator, and that's approximately 3.16. Now, I'm not going to use that. I just need to know that number to know that, okay, in this case, 4 would be potentially my hypotenuse because it's the biggest or longest side of the 3. So again, this one's been worked out. You can look at it. Again, whenever they're not all the same type of number, one's a square root and the others are not, always find out the value of that square root to see whether or not it's the biggest side or not, so you know which one to put in for C in the formula. Okay, moving on, we're going to go to these. Now, these are referred to as special right triangles. Special right triangles. So what I'm going to do is down here below, I'm going to write the rules for the special right triangles. The first one is called a 45, 45, 90 triangle. Now, since two of the angles are equal, 45, 45, here's my right angle, that means this is called an isosceles right triangle. Isosceles means two sides are the same. So in this case, the two legs are both equal. So let's say, for instance, that's x. Then that means this one's x also. Sorry about that. Well, then the hypotenuse is the longest side, so it's got to be something bigger than x. Well, the rule here is you multiply by square root of 2, and that's how you get the bigger side. Then we have what's known as a 30, 60, 90 triangle. So 30, 60, 90. Now, one of the things you'll learn in geometry is this relationship. The reason the hypotenuse is the longest side is because it's across from the right angle, which in every case is the biggest angle in a right triangle. So in this particular case, everything is related to what we call the short leg. The short leg is the one across from the smallest angle, the 30. That's the short leg. So in this case, we'll call it x. Then the long leg, which is across from 60, it's the leg, not the hypotenuse, it's bigger than the short leg. How much bigger? It's x times square root of 3. And then the hypotenuse, again, which is the longest side in this case, is the short leg, which is x, times 2. So it's 2x. So that's the relationship. Those are the rules for each of those. Now what we're going to do is apply those rules to working these problems. So real quickly, in a 45, 45, 90, this is a leg because it's across from 45. Since it's 45, that means this is 45, so it's isosceles. Those are the same, which means B is also 9. And then going back to my rule down here at the bottom, to get the hypotenuse, I take the leg and multiply by the square root of 2. So I get, I get 9 times square root of 2. Again, in number 6, 45, 45, 90. So again, these are the same, so y is 7 square root of 2 over 2. It's got to be the same as the other one. To get x, I get 7 square root of 2 over 2. Oops, I wrote that over 2 times square root of 2. Now what happens here? Well, that ends up being 7 square root of 4, but the square root of 4 is 2 all over 2. Well, what happens to 2 is they cancel and I get 7. Now, what if it's an instance where you have to go backwards? Say, for instance, they give me the hypotenuse and I've got to find the leg. Well, then you just do the reverse, which is instead of multiplying by square root of 2, you would divide by square root of 2. Okay, let's do the 30, 60, 90 triangles now. So, in this case, they give me the long leg. The first thing I need to find is the short leg, and that's true in any 30, 60, 90. Always find the short leg first. Now, how do I get the short leg? Let's go back to my rule. The rule was you go from short leg to long leg across from the 60 by multiplying by the square root of 3. So here I'm going backwards. I'm going from long leg to short leg. So what I do, I divide by square root of 3. So I'm going to write it over here on the side. So B would be 9 square root of 15 over 10 divided by square root of 3. Now, I can't divide the 3 into the 10, but I can divide the 3 into the 15 because they're both under square roots. So 3 goes into 15. Sorry about the phone. Anyway, square root of 3 goes into 15 again because they're both under square root, so I end up with 9 square root of 5 all over 10 because 3 goes into 15 5 times. So that becomes my long leg. Now, how do I get the hypotenuse? which is A. Well, come back over here. To get the hypotenuse, it's 2 times whatever x is. Now again, x is the short leg. Well, I just found the short leg. The short leg is B right here. So what do? I take that number and I multiply it by 2. So A would be 9 square root of 15 over 10 times 2. Well, 2 goes into 10 5 times. So I end up with 9 square root of 15 over 5. So one of the things you'll find in these geometry lessons is you don't always find necessarily the variables in order. You find based on the rule itself. So I found B before I actually found A. So again, I'm going to pause the video. I'm going to work out number 8 over here on the side, and then you can check your work. So a real quick explanation of this one. They gave me the hypotenuse. First thing I always find again is always the short leg, my x, the one across from 30. So in this case, that's V. Now, how do I go from x to hypotenuse, the short leg to hypotenuse? I multiply by 2. So to go backwards from hypotenuse to short leg, I divide by 2, which is 2. So now the short leg is 2. How do you get from short leg to long leg? Come back, short leg to long leg, you multiply by square root of 3, so it becomes 2 square root of 3. So that's a real quick lesson over right triangles using Pythagorean Theorem and the special right triangles 45, 45, 90, and 30, 60, 90.